Let me quickly create a cluster and the node group. So today we'll see how to deploy our first application on Kubernetes cluster. So once the status is changed to like a created, then we can able to create the node group. Okay, right now it's showing creating, right? So it should change to created for active, and then only we can able to create the node group, right? So till then, let's try to revise what all permissions or what all parameters that we have provided while creating the node group and the cluster. Okay. Right. So let me ask you a few questions from yesterday's class. Okay. So what is the policy that we used for creating the cluster, EKS cluster? What is the policy that we used for creating the
Amazon EKS cluster policy.
yes, Amazon EKS cluster policy? Okay. And what are the policies that we used for creating the node group? Or what are the policies that we used for creating the node group? So we use three policies, right? So what are those three policies that we used for node group? People have joined yesterday's class. Neetu, Sada, Vijay, Suresh.
EKS worker node policy and EC2 container registry policy.
EC2 container registry policy. Okay. What is the first
Read
one?
only. Amazon EC2 container registry read only.
Okay. One. And
And
remaining two?
Amazon EKS worker node policy.
Correct. Two, three. Third one?
Third one, not remember.
Vijay.
Something
Sada.
CNI something CNI policy.
CNI policy. Okay. So these are the three policies, right? CNI policy, EC2 container registry read-only policy, and the worker node policy. Okay. So what is the purpose of using EC2 container registry read-only policy? For pulling the images from the ECR, for deploying the Docker image from ECR to EKS. Okay. And the CNI policy, why do we use CNI policy? For managing the networking on the Kubernetes pods, the worker nodes, right? For allocating the IP addresses, for managing the IP addresses, okay? And other networking stuff will be managed by the CNI. So for providing this, the required permissions to the CNI plugin, we are attaching this CNI policy. And the other one, worker node policy. What is the purpose of worker node policy? What happened? Sada, Vijay, Sirish. So Bala didn't join yesterday. Sapesh didn't join yesterday. Ravi, I'm not sure if you have joined yesterday or not.
No, I haven't joined.
You didn't join, right? Yeah. So Neetu, Sada, Vijay, Sirish. So what is the purpose of the worker node policy? For creating a connection between the worker nodes and the control plane, nothing but the master node. Okay, right? Because after creating the cluster, we are creating the node group. That means we are creating the worker nodes. Okay. Now, in order to communicate with the control plane, the worker node should have that permissions, required permissions. So that's why we are attaching this policy, worker node policy. Okay. So these are the three policies which are important for creating the node group, and the Amazon EKS cluster policy, that is the policy which is important for creating the cluster. So one policy for the control plane, meaning for the cluster, and the three policies for creating the node group, worker nodes. Okay. So Sapeksh, Ravi, and who else joined today? Bala. Sapeksh. Yeah. So three of you, let me just give a high level overview what we discussed in yesterday's class. So I explained how to create a cluster, the Kubernetes cluster, and then how to create a node group. Okay. So cluster is nothing but the collection of master node and the worker node. Nodes are nothing but the EC2 instances here. Okay. What is node? Node is nothing but a computer. So in AWS, we are using EC2 instance. Correct. Okay. Now what is Kubernetes cluster? The cluster contains group of nodes. So here we have master node, the main instance, which will takes care of all the key operations like scheduling the pods and communicating with the other important Kubernetes processes. Okay, validating the incoming request. Okay, right, and storing the configuration data. Right, running the key controllers. There are some important processes which are running on the master node. So I already explained in the architecture class. Key components of Kubernetes architecture. Okay, API server, kube controller, kube scheduler, etcd. All these are the components running on the master node. Okay, so we will not be deploying our applications on the master node. Okay, we won't deploy the applications on the master node. We will be deploying the applications on the worker node. So we can have n number of worker nodes. In Kubernetes, master node is managed by the AWS. We will not manage the master node. It's not visible to us. Okay, we will not log into the master node. We will not do anything on the master node. Everything is handled in the backend. But whereas worker nodes, we will be creating the worker nodes. Okay, and upgrades, any security patching or in any type of configuration, we will do it on our own. Right. But however, if you also want to eliminate this management of the worker node, we have one more option. What is that option, guys? So if I do not want to manage the worker nodes as well, what is the option that we have? Can anybody answer? So if I don't want to manage the worker nodes as well in EKS, what option do we have?
Fargate.
Fargate, right? Yeah. So we have the Fargate model, same like ECS cluster. How we have two options, right? In ECS, we have Fargate and we have EC2 model, and we also have the external. So in EKS also, we have Fargate and worker node model. That means if you want to manage the worker nodes, then you will use the node group, or else you can use the Fargate model. Okay, same like ECS. It's almost similar. Okay. And so in ECS, we basically call it as task, where we are running the containers. Right? Inside the task, we are running the containers. And in Kubernetes, what do we call that component?
Pod.
Pod, correct. Okay. So in ECS, it's task. In Kubernetes, it's pod. Inside the pod, how many containers can we run? One or more than one container. But recommended is only one container. Remaining containers, we call it as sidecar container. The same concept in ECS and same it is in EKS as well. Okay, great. So what are the three components that we have on the worker node? In the Kubernetes architecture, I explained the components, right? So what are the three components which are present on the worker node? People have
Proxy, kubelet, and container runtime.
Correct. Kube proxy, kubelet, and container runtime. On the master node, API server, etcd, kube controller, kube scheduler.
And schedule.
Yeah. Okay. Great. Vijay, do you have any questions?
Yeah, Naveen, I want to ask. Sorry to interrupt.
No problem.
Can you describe about the container runtime? I missed that point.
Yeah, container runtime is just a a process. Process here is nothing but a software, Vijay. So all these components are nothing but packages or the softwares. We are calling it as softwares, okay? But the terminology we are using component, Kubernetes components, okay? So it's nothing but a process which is running on the, which will be running on the worker node for allowing us to run the containers. So if you want to run the Docker containers inside the pod on your worker nodes, so we need a container runtime process running on our worker nodes. Okay, clear, Vijay? So it's simple
Yeah.
answer. If you want to run the containers on your worker nodes, one process that we require is container runtime. It's a runtime process which will allow us to run the pods. Okay, kubelet,
Yes.
you know, it creates a communication between the master node and the worker node. Okay, kubeproxy, it takes care of IP addressing, networking related tasks on the pods. Okay,
Yes.
right, yeah, great. Now, so let us check if the cluster is created or not. Yeah, cluster is created. You can see the status as active. Now let us quickly go ahead and create the worker nodes. So go to compute. Let's click on create node group, add node group. Let me give the node group name as P24 hyphen node group, worker node, role. Next. So here we selected spot capacity. Why am I selecting spot capacity? Why not on demand? What is the reason? So what is the purpose of selecting the spot capacity? Why not on demand? Neetu, Vijay, Sada. Forgot? Sorry. Okay, while creating the node group, I'm enabling this SSH option, remote access to nodes. So I'm enabling this option so that we can log into the worker nodes, like how we can able to log into the normal EC2 instances. So similarly, if you want to log into the worker nodes, Kubernetes worker nodes, you need to enable this option. Okay, so in yesterday's class, I already explained all the steps for creating the node group and the cluster. So people who have missed yesterday's class, please watch the recording. You will understand each and every step. Don't worry. Right. But I just missed this step. Okay, so we need to enable this option in order to log into the worker nodes. Then we can use the key pair. You can see I'm using this Linux VM key pair. Using that key pair, we can able to log into the instance, worker node instances. And here I'm selecting a security group for the worker nodes. Okay, I'm using default VPC security group. Okay, or else you can create a separate security group and then you can attach that security group. That is also fine. Right? So now, let me quiet, right? Yeah. So what is the purpose of using spot instance type while launching the node group instead of on-demand instance? Adil explained about this different instance categories, and even I mentioned it yesterday. So if we use the spot instance type, we can get almost 80 to 90% discount on the pricing compared to the on-demand instance. Let's say, for example, the T2.medium instance is costing us $100, assume, per hour or per day. Let's take an example of per 1 day. the T2.medium instance type is costing us $100. Now, if you go with spot instance type, okay, spot category, for the same instance type, T2.medium, you can almost get it for like $10 or $20. Okay, right? So that much variation will be there in the price for the spot instances. But however, there is a drawback in the spot instances. Can anybody answer? I explained this in yesterday's class. It's just one day, guys. Vijay?
In the spot, it is not guaranteed for the instance. For example, if a crash happened, like sometime it will crash happen, right? It is not responsible for the AWS. Something is there.
No, it's not about the instance termination or instance crash. Okay, so basically, you are close. You are close. Your answer is close. But the thing is, let's say if you are using the spot instance type, so there is no guarantee for the instance availability. It's not about instance termination or
Yes,
instance crash.
availability.
AWS cannot guarantee about the instance availability. Okay, let me give an example. So guys, everyone please focus. Okay, I'm explaining the instance type here. Let's say you are going to a 5-star hotel, right? Maybe in India or outside India. Okay, now we have like a couple of rooms available, or like 2 to 5 rooms available in a hotel, right? And you want to check in, right? So we have, let's take an on-demand room type. Okay, let's take on-demand room type. So for the on-demand, you will be paying like more money, right? Whatever the amount that hotel is quoting. So it will be, let's say it's $100 or $200, $300. You will be paying that amount, and you will be like staying in that particular room without any tension, right? So next day, till the same time, till checkout time, you don't need to worry about the availability of the room. Okay, so you can just stay relaxed, and next day you can check out whenever you want. Or if you want to extend, you can extend the stay. If you want to extend 2-3 days, yeah, you can pay the rest of the amount and you can extend the stay. Okay, so that is a on-demand kind of stay. Okay, hotel room. Now let's consider the same thing with the spot type of hotel room. Now the same room, you are getting for almost 70 to 80% of the discount. Let's say for the on-demand room type, you are paying $100, but for this spot room type, you are paying only $10 or $20. Okay, and you are getting the same luxury, all the amenities, everything are getting the same. Everything you are getting for the same price. The less price, like $10 or $20, right? Everything, whatever that you are getting for the on-demand, you are getting the same thing, but for the lesser price. Then what is the problem here in the spot room type? So the hotel management might ask you to leave at any time. Let's say if the other person is coming, let's say Sapeksh is staying in the spot room type since 2 days. Now today I'm going to the hotel. I'm telling hotel management that I will pay more than what Sapeksh is paying. Let's say Sapeksh is paying $10. I'm ready to pay $20. I need that room. So now hotel management will ask Sapeksh to please leave that room and do the checkout. So that is the challenge with the spot. So there is no guarantee on the availability of that particular instance. Got it, guys? But the on-demand, you will be paying more money, but you don't need to worry about the availability, right? You will get all the benefits, amenities, everything you will get, but you are paying some more money, and you don't need to worry about the availability of the room. You can check out whenever you want. So that is the difference between spot instance type and on-demand instance type. Whenever you're creating an EC2 instance with the on-demand, you can stop anytime, you can stop anytime, you can terminate, you can create anytime on demand. On your demand, you can create that instance, stop the instance, terminate the instance, and you do whatever that you want. But in the spot category, you can create the instance from the available instance types, right? And there is no guarantee about the availability of the instance, so those instances can be taken back by the AWS at any point of time. Okay, so then which purpose we will be using these spot instances? For less critical task, not for the production based applications, maybe for some POC task, maybe for some testing task, right? For those kind of task, we can able to use this pod instances. Right now, we are just practicing the Kubernetes, right? It's not a real-time scenario. We are just using it for the practice purpose. So we are not worried even if the instance is taken back by the AWS or it got terminated. So that's the reason I'm choosing the Spot instance to save some money. Clear? Is everyone clear on this? Any doubts between Spot and on demand? No, right? So please remember this. Okay, don't forget. Yeah, great. Come back. So now the node group is still creating. Yeah, you can see the node group is created. You can see the node group. How many node groups we created? Just one node group. And the name of the node group is B24 node group. And the status is showing active. What is node group here? Nothing but collection of worker nodes. Can we see the master node? Guys, can we see the master node in the EKS dashboard? Is it possible? Yes, no?
No.
No. Okay.
No.
But however, we can see the worker nodes. You can see the worker nodes. See here. Worker nodes 2 and the node 1, node 2. What are worker nodes? Node is nothing but a computer. It's nothing but a EC2 instance. Linux machines, Linux computers. Okay. So now, if you just open this in a new tab, it will show you all the details about that particular worker node. Okay. What operating system we are using, what is the AMI, what is the instance type it is using, when it is the created, okay. And yeah, when it is created, last transition time, node group name, and the CPU capacity, memory capacity, how many pods are created, right? You can see that already 4 pods are running on these worker nodes. So you might get this doubt. Naveen, like till now, we have not created any pods manually, right? We have not deployed any application. Then how come already 4 pods are running? Value 4 pods, 17 pods. Yeah, so total we can accommodate. So this 17 is total, we can accommodate 17 pods, out of which 4 pods are already running on this worker node. So you might get this doubt. How come these 4 pods are running? These pods are created by the system. Okay, so these pods are created by the Kubernetes in the backend. We have not created these pods. These are the system created pods, which we can ignore. Okay, we are not going to do anything with those pods, right? And this is about the CPU and memory utilization of that particular worker node. So how much CPU is being utilized and how much CPU is still available. Okay, you can see here. Still 85% of memory is left. Right? So this is about the worker node. And if you come back, you can see the same details about the second worker node. And you can also see the same thing in the EC2 dashboard as well. Right now, you can see in Mumbai region, we have 2 instances, WebTire and the build server. WebTire is in stopped state, build server is in running state. If I refresh the page, you can see we have 2 more instances. So these 2 instances are the worker nodes. Okay, the same instances. What you are seeing here, these are the same instances. Okay, 172, 31, 45, 229, 7, 3. You can see here IP 172.31.7.3 and the second one 45.229. Okay, so you might get this dot. Naveen, for this worker node we have 1 private IP address, but for this worker node we have 2 private IP addresses, right? So this is a secondary private IP address, guys, right? And if you scroll down to networking, you can see here the secondary private IP addresses. So these are the IP addresses which will be allocated to the pods which are launched on this particular instance. Okay, so whenever you are launching the Kubernetes worker nodes, so secondary IP addresses will be allocated to your worker node based on your instance type. What instance type you are launching? T2.medium, T2.micro, T3.medium, depends on your instance type. That many number of secondary IP addresses will be allocated for the instance. Okay, and what is the purpose of this IP addresses? Whenever we are launching any pod on this particular worker node, so one random IP will be allocated to that particular pod. So even pods will have the IP address. Even in the ECS also, we have IP address allocated to the task. Correct. So even here also, we have the IP address allocated to the pod for the pod communication. Okay, to enable the communication between the pods, right? We need a IP, dedicated IP for the Kubernetes pods. Okay, right. And we call it as secondary IP addresses. Okay, just name it as worker node 1. Just for our understanding purpose, I'm just tagging it as worker node 1 and worker node 2. But however, you can rename it as anything of your choice. It should be meaningful. Okay, I'm naming it as worker node 1, worker node 2. Or else you can name it as EKS worker node 1, EKS worker node 2, like that. Okay, fine. So now we have the cluster ready and the worker nodes ready. So what is the next task? We need to deploy the application on the Kubernetes cluster. Okay. So do anybody have any questions still here? Before I move forward, if you have any questions, you can please ask. Vijay, you have any questions?
No, Naveen, as of now, I'm good.
Good.
Yes.
So this green color box is cluster. Tapeksh, I hope you are able to understand, right, what I'm explaining. Tapeksh, Bala, Sada.
Yes, Naveen.
Yeah. Okay. Right. Because you people have missed few classes, right? The last one. Sada, I think you have not missed anything. Yeah. Okay, so this is the EKS cluster. And now let's draw a master node. This is the master node, right? And next, let's create 2 worker nodes. Okay. So now this is our typical Kubernetes cluster, okay, with 1 master and multiple worker nodes. So in our case, how many worker nodes we created? We created 2 worker nodes, right? You can see here, we have 2 worker nodes. That is the reason I drawn 2 worker nodes here. This master node is not visible to us. It's running in the backend. Okay, all the high availability, okay, scalability and updates, patching, security, everything is handled by the AWS in the backend. So you will not see this master node, but yeah, whenever you are creating the cluster, automatically we are creating the master node in the backend. Please remember this. Okay. So this is master node, worker node. Worker node 1, worker node 2. Okay, great. So now, what is our agenda? Let's say this is our build server. Okay, and so this is the developer, right? So these 2 people are Java developers. Okay, now what they are doing, they are writing the code on their local system, and once they are done with writing the code, what they will do, guys, so please try to be interactive. Please unmute yourself and feel free to answer. That's completely fine, even if it is wrong, but give it a try. Okay, so it will be revision for you only. Okay, so now once these developers are done with writing the code on their local system on their laptop, what is the next step? What they will do next?
They will push into the Git repository.
Okay, they will push the code to where? GitHub repository. Correct. Let's say we have a repository here with the name customer. Okay, what's next? Once the developers push the code into the GitHub repository, so what is the next step? I want answers from everyone, not just 1 or 2 people. So once we are done with pushing the code, in the sense, once developers are done with pushing the code into the GitHub repository, what is the next step? What we have done for the ECS deployment, Docker deployment, normal instance deployment. So what is the next step, guys?
And we can generate the artifact from the customer folder.
But before that, what we need to do? Need to
Clone.
clone. Clone from where? From GitHub repository to which server?
Build server. No?
Correct. So build server. Okay. So we are cloning the repository, nothing but we are pulling the code, right? We are downloading the code to the build server.
Build server.
Right. Okay. So now we have the code ready. Whatever the code which is written by these developers, right? We created a pull request and we merged the code into the main branch. Okay. By assigning a reviewer, and reviewer has reviewed the code. They have given the green signal, and then we merge the code into the main branch. We, in the sense, developers. Okay. Developers will merge the code into the main branch. And once they are done with merging the code into the main branch, we as a DevOps engineer, we are cloning this repository to the build server. Okay. Done. Step number 1. What is the step number 2? These steps are very, very important. Okay, because these steps will be daily task for the DevOps engineer. Whatever the steps I'm explaining now, these are the regular job that we do as a DevOps engineer on a day-to-day basis. Because most of the people, they ask, Naveen, what do you do on daily basis as a DevOps engineer? Okay, what are your daily tasks? Right. So these are the regular tasks that we do. Cloning the repository from developer repositories, right? Cloning the code from the developer's repositories to build server. Step number 1. What is the step number 2? Vijay, you mentioned, right? What is the step number 2? Please be fast.
Artifact file.
So what do we call that?
Byproduct. We are generating the byproduct from the build server.
Yeah, you are saying correct only, but what do we call it? You are saying like we are creating the artifact, but what do we call that process? Building the code, right? Building the application.
Building. Okay, correct.
Build the code. So nothing but it will create the artifact. Okay. Step number 2 is done. What is the next step?
And we push that artifact to ECR.
ECR. So here artifact means, what is the artifact here?
.jar. .jar.
So before discussing Docker, we created jar. That is also artifact. Okay. But once we discuss the Docker concepts, we are creating the image, right?
Image.
So this artifact is nothing but the image.
Image.
Docker artifact. Okay. Now we need to push this image to Docker registry. So what is the registry that we are using here? ECR.
ECR.
And what are the other registries that we can use instead of ECR? Other alternatives that we have apart from ECR.
JFrog.
JFrog.
Docker Hub.
Docker Hub, correct.
Docker
And
Hub.
Nexus, right? These are the popular Artifactory store. JFrog, ECR, okay, and Docker Hub, Nexus, etc. Okay. In Azure, we have ACR, Azure Container Registry. Okay. In Azure, it's the same concept, but we are calling it as ACR, Azure Container Registry, for storing the images. And EKS, we are calling it as AKS. In Azure, we call it as AKS. Okay. Great. Now, what is the next step, guys? So pushing the image to the ECR is completed. What is the 4th step? What we have done in ECS? We deploy the image from ECR to ECS cluster, correct? So we created a task definition file. There we have mentioned the image name, and then we deploy that image on the ECS cluster. So here also it's the same thing. Okay. So we will be having the image in ECR, right? And that image should be deployed on any of this worker node, either worker node 1 or worker node 2. From where it is pulling the image? From ECR. So that will be our task. Okay, is this clear, guys? Everyone, are you clear with these 4 steps? Cloning the repository, building the code, pushing the image to ECR, okay, and then deploying that image on the EKS cluster. Please remember these 4 steps. Okay, even if I wake you from the sleep in the midnight, if I ask this question, you should be able to answer. 4 steps, very, very important. Cloning the repository, building the image, nothing but building the code. So what is happening in the building the image? Nothing but you are building the code. It's creating the artifact, and that artifact is packaged inside the Docker image. And that image we are pushing to the ECR, and the same image should be deployed on the EKS cluster. Now you tell me this, the answer to this question. So who will decide so when we are trying to deploy the image on the EKS cluster, who will decide which worker node should be used for running that particular pod? So I want to deploy that image on the EKS cluster, but the pod will be created either on the worker node 1 or worker node 2. Okay, let's say I want to just create one pod. I want to create only one pod, one replica. So pod is nothing but a task. In ECS, you are calling it as task, right? In Kubernetes, we are calling it as pod. What does the pod contain? It contains the containers, right? Now, who will decide the worker node here? Which worker node will be used for deploying, for creating that pod? So there is one component in the master node which will decide that. Which component will decide it? Out of 4 components on the master node, one component will decide this particular task. What is that component? The name itself will tell you. The component name itself will clearly explains that.
Control manager.
No.
Cube scheduler.
Cube scheduler.
Kube scheduler. Okay, kube scheduler will decide the worker node. Okay, which worker node is available based on the CPU resources, memory resources, storage resources, right? Based on the computing resources, kube scheduler will decide on which worker node it has to schedule the pod. Please remember it. Okay, kube scheduler will schedule the pod to the available worker node. Which worker node is busy, which worker node is freely available, right? So this will decide based on the computing resources. And then it will allocate that pod either to the worker node 1 or to the worker node 2. Okay, and other components are API server, etcd, kube controller or controller manager. Okay, right. So now this is the task. I hope you understood. What is the next task? We need to deploy the image on the Kubernetes cluster. What will happen? It will create a pod. So let's say if I want to create one pod, it will create a pod either on the worker node 1 or worker node 2. Let's say it is creating on the worker node 1. This is the pod. Okay, our customer image will be deployed and it will create a pod. So what will be having inside the pod? It will create a container. So what is this? Container. Okay, so this is our next task, right? Before deploying our customer microservice, let us try to deploy a normal application. Let's try to deploy the Nginx application. Okay, because we have done the same thing for the ECS as well. Before deploying our front-end application, I explained how to deploy a Nginx application, right? Today let us deploy the Nginx application. So on Monday we'll start deploying our actual backend application. And as I told you yesterday, so today and tomorrow you try to complete that backend application deployment on ECS cluster. By Monday morning, I want everyone to complete that task. So we have 2 days time, today and tomorrow. Hardly it will take 10-20 minutes, guys, or maybe 1 hour max for creating the cluster, creating the task definition, creating the service, right? And you need to create an image first. You need to build the customer image, push the customer image to the ECR, and that image should be updated in the task definition file and deploy it using the service, create a service. So that is the task. Okay, so once you're done with the task, please take the screenshots and upload in the LMS, right? Okay, so now what we need to do, so in ECS, it's very easy. right? So in ECS, we have the task definition concept and we have the service. So we need to create the task definition, and while creating the service, we need to refer the task definition file. Once you create a service, automatically the task will be created on the Kubernetes. Sorry, the task will be created on the ECS cluster. But when it comes to the Kubernetes, that is not the case here. Okay, it's little difficult. I mean, difficult in the sense like we need to follow more steps in order to deploy the application. It's not straightforward here. Okay, in Kubernetes, it's not straightforward. Okay, so first we need to create a separate instance, or maybe you can also use your local laptop. Okay, or you can create a separate EC2 instance. Okay, so what I will do here, I will install a CLI tool. Okay, I will install a CLI tool. What is that CLI tool? kubectl CLI, Kubernetes command line tool. What is the meaning of kubectl? Kubernetes command line tool. Okay, so using this kubectl commands, we can deploy the application on the Kubernetes cluster. Okay, so how we are going to deploy the applications on the Kubernetes cluster? We need a separate computer. Okay, it can be your local machine, local laptop or computer, or you can create a separate instance. Right now, on this instance, you will install the kubectl CLI, and then you will provide the permissions to the EKS cluster. Okay, we need to configure the AWS credentials, right? Access key and secret key. We need to configure those credentials on this particular instance, and then we need to install this kubectl CLI, and then by running some commands, we can able to deploy that image on the Kubernetes cluster, either worker node 1 or worker node 2. Clear, right? So now what we will do, so I have already a build server running on my AWS console. You can see here the build server, it's running, it's showing in the running state. Let us connect to that build server. Right, clear the screen. Unless we have two folders, customer and front-end folder, that's fine. Let's check if we have any images. It's fine. Okay, but anyway, we are not going to use any of these images now, right? We have some images here on this instance, but we are not going to use any of these images. So let me delete all these images. Docker system prune -af. So I'm deleting all the images from my system, all the unused images. It will free up some storage. You can see reclaimed space 1.03 GB. Docker images. Right now you can see we do not have any images, and if you type ls, we have customer folder and the front-end folder. But even now we are not going to deploy these applications, customer or front-end applications. Okay, so let's try to deploy the Nginx application. Right, it's a web server application. Now let us try to check if we have AWS CLI installed on our instance or not. So type AWS and hit enter, and now you should able to see this. Okay, usage AWS and so the following arguments required. Right, that means AWS is installed. Now we need to configure the credentials, guys. We need to provide the permissions, because from this build server we want to communicate to the EKS cluster. Okay, from this particular build server we want to communicate with the EKS cluster. That is the reason we need to provide the credentials of the AWS account where our EKS cluster is present. Okay, our EKS cluster is present in this particular account in Mumbai region. So we need to provide those details here. We need to configure the credentials. What is the command for configuring the AWS credentials? Do anybody remember? AWS command for configuring the AWS credentials. Do you know?
AWS configure.
AWS configure. Okay, it's AWS space configure, right? So if you have not used it till now, you will be using this command going forward. Okay, AWS configure, hit enter. Now we need to provide the access key. Where we can find this access key and secret key? Where can we find this access key and secret key? IAM. Go to IAM. And so I'm using the root account, so I can directly click on this my security credentials. But if you are using IAM user, then you need to go to that particular user section, and then let's say if you are using the let's say I created a user Cloud Nation, right? So what I will do, I will open this user, and here I will go to the security credentials. So if you scroll down here, I can create the access key. You can see here we can able to create the access key and secret key. But if you logged in as a root user, right, if you created your Kubernetes cluster from the root user and all, then just simply click on IAM and you will see the quick links, my security credentials. And if you scroll down, here you will find access keys. Okay, so let us create an access key, create access key and enable this checkbox. Right, let me download this CSV file. Right, so I have downloaded these credentials. Now let me copy this access key, come back to the instance and paste it. Done. Next, let's copy the secret key, come back. And so which region are we using now? Mumbai region, right? You can see here. Our Kubernetes cluster is present in the Mumbai region. So what is the region code of Mumbai? What is the region code of Mumbai? AP-South-1. AP-South-1. Enter and enter. Now we have successfully configured the AWS credentials on our build server. Why we configure those credentials on the build server? Because this is the server we are going to use for deploying our applications on the Kubernetes cluster. From this instance only, we are going to run the kubectl commands. Kubernetes command line tool. Okay, we are going to run the kubectl commands for deploying the application, for deleting the application, for updating the Kubernetes application, or anything. We are going to use the kubectl, and we can also use Helm charts. Okay, later I will explain what is Helm, how to deploy the application with the Helm. It's related to the Kubernetes only. Helm is related to the Kubernetes only. That we'll discuss later, right? So what is the next step, guys? Now we successfully configure the credentials. So what we need to do next? We need to install kubectl CLI tool. Okay, right now we have this build server and we configure the AWS credentials. That is completed. Next, we need to install kubectl CLI tool. Okay, so for that you can open my GitHub repository. Go to my GitHub repository and go to repositories, container orchestration. Click on Kubernetes initial setup.md, the last file. So here, yeah, this one you can see here, right? Install kubectl CLI tool on EC2 instance. Okay, just copy these commands and paste it and hit enter one by one. Copy, enter. So these are the commands for installing the CLI tool. Let's copy the next command, chmod +x. That means we are providing the execute permissions to this particular file, kubectl file. Enter. And next, we are setting up the environment variables. Done. And so let's execute this command. Let's check the version. Right, so we have successfully installed the kubectl on our system. Right, so you can actually check these comments in the official documentation, or you can also check it in the Google or ChatGPT. Like, what are the steps for installing the kubectl on the Linux machine, Amazon Linux machine. Okay, so in the official AWS documentation, you can find these commands. Right, so now we are done with configuring the credentials. We are done with installing the kubectl CLI tool. Now we have one more step which is left. So in the same documentation, if you scroll to the bottom, you can see here, update cluster information in the kubeconfig file. Update cluster information in kubeconfig file. Let's copy this command and paste it here. Sorry. I need to update the cluster name. So our cluster name is batch 24 -EKS cluster. Copy the cluster name and paste it here. Okay. So here, just copy paste the same command and replace this cluster name with your actual cluster name. Okay. So make sure that you are changing the cluster name here, right? Right. AWS EKS update kubeconfig -- name cluster name -- region and the region code as well. So the last we need to change the region code. It's AP-south-1. Hit enter. So now you can see you are getting this message. Added a new context so and so to this particular file. What we are actually doing, we are updating our Kubernetes cluster information, right? We are updating the Kubernetes cluster information into this particular kubeconfig file. So where you can find that kubeconfig file? Inside the root directory, we have home. Inside the home, we have EC2 user, right? Inside the EC2 user, you need to go to the .kube folder and the config file. Okay, so we need to update our cluster information in the config file by running this command. Okay, so let me show you how it looks. Cat space, let's copy this path and paste it. So this is how the file looks, the kubeconfig file looks. API version, clusters, the cluster certificate. Okay, now let's come back to the cluster, go to overview. So you can see this certificate authority, right? It's a secret key. What is this certificate authority? It's an encrypted key. It's a secret encrypted key. Now this certificate authority will be updated in this kubeconfig file. You can see here, certificate authority data, LS0TLS1. LS0TLS1, right? And ending with SOK. Ending with SOK, right? So we are updating that certificate authority in this kubeconfig file and also the ARN of the cluster. So you can see the address of the cluster, region, south1, account ID, and the cluster name. Right? So we are updating some cluster important details in the kubeconfig file. Then only we can communicate with the Kubernetes cluster with the kubectl command. If you do not update this kubeconfig file, then you cannot run the kubectl commands. It will throw the error. While running the kubectl commands, it will throw the error. It cannot communicate with the cluster. Okay, let me explain here. So this is our build server. Right, this is our build server, or it can be your laptop also. It can be local system also. But what we need to do first, we need to configure the AWS credentials, right, for providing the permissions to the EKS cluster. And next, we need to install kubectl command line tool. Next, we need to update kubeconfig file. We need to update kubeconfig file. Why? Because whenever you run this kubectl command on this particular instance, so it should send that data. Okay, it should send that request to your Kubernetes cluster. But how this command line will understand which cluster it should reach out to, which account it should reach out to, which region it should reach out to, it should have some information, right? It should have some information stored on this particular instance. So that's why we are updating this kubeconfig file with the Kubernetes cluster information. Okay, right? By just running this one single command, it will update that cluster information. AWS EKS update kubeconfig file with the cluster information. And then you can run the kubectl commands. Okay, so we are almost done. Clear the screen. Now let's run the command kubectl get nodes. So this is the first command, kubectl get nodes. Let's hit enter. See, it's giving the response. whenever you're running this command on this particular instance, it is trying to communicate with our Kubernetes cluster and giving back the response to the build server. Okay, you can see these are the worker nodes we have. kubectl get nodes. This is the command for checking the total number of worker nodes running on our EKS cluster. How many worker nodes? 2 worker nodes. So if you want to see more details about these worker nodes, the same command you can run -o wide. Now we can see the private IP address, public IP address, which image is being used by this particular worker node. Okay, all these details you can able to check here. Okay, what is the additional argument we are passing here? -o wide. Without -o wide, it will just display the worker nodes, right? But with -o wide, you can able to see more details like internal IP, external IP, and the OS image, etc. Okay, fine. Now let us deploy our first image on the EKS. Okay, so what is the command I'm using here? Kubernetes run pod name and then followed by the image name. Okay, so what is the command? kubectl space run space pod name and then followed by the hyphen image and then image name. So what is the image name that we need to give here? Nginx, Nginx. So from where it will get downloaded, guys? If I'm giving the image name as Nginx here, from where this image will be pulled? From which location this image will be pulled?
From the Docker Hub.
From the Docker Hub. Okay, right. And the pod name, let's give the pod name as web app. I'm giving the pod name as web app. Okay, so let's hit enter. Right, now we can see pod web app is created. So what do we have inside the pod? What does the pod contain? What does the pod contain here?
Containers.
Containers, right? Yeah, you can see here worker node, pod, and inside the pod container. Inside the container application, right? So now, what is the command for checking the worker nodes? What is the kubectl command for checking the worker nodes? Just now I executed, right? The first command, first kubectl command. What is that command?
kubectl get nodes.
Kubectl get
Nodes.
So it is displaying the nodes. Now, similarly, you guess the command for checking the pods. What will be the command for checking the pods? Just give it a try.
kubectl get pods.
Correct. kubectl get pods. It's showing the pod details, web app, and so and so. The pod name is web app, ready, 1 by 1, status, running, restart 0, age. So what is the time? When it is started, when the pod has started, 67 seconds ago. How many times it got restarted? 0 times. So there was no issue. When there is some problem, pod will try to restart again and again and again. Okay. But right now we can see 0 restarts. That means pod is healthy. There is no issue. And the current status also is showing running status. Okay. That means pod is successfully running. Then what is this 1 by 1? Can anybody guess what is this 1 by 1? Compare with your easiest task. What is this 1 by 1? No? No guess? Vijay, Neetu, Sada, Pala.
We pulled one image is deployed.
You are close, but it's not image.
Like running one by one in pod, one service.
Running what, Neeta?
One service, like one pod.
No. So here there is no concept of service. In Kubernetes, there is no concept of service like how we have in ECS, we have service, right? So here it's a different concept that we will discuss later. Okay, but it's not service. So what is this one by one?
Are we requesting one pod is created?
No, it's not pod. You're missing one key component. Bala. So what is this one by one? What do we have inside the pod?
Container.
Container.
Yeah, so this one by one represents the container. Okay, that means, so we are actually trying to create one container. On the right hand side, it's the desired number of containers that we want to run. On the left hand side, it's like how many active containers are running. Okay, running containers. So these two numbers should always match. Okay, LHS is equals to RHS, right? So whatever the number that you're seeing on the left hand side should match with the right hand side. Okay, so one is the desired number of containers, like how many containers should be actually running and how many containers are running currently. Okay, right, one by one. So that means one container is running without any issues inside the pod. This is the pod count. Okay, now if I want to know more details about the pod, what argument can I pass here? For this particular command, if I want to know more details about that particular pod, let's say on which worker node that particular pod is running. So what is the additional argument that I can pass here? Minus O white, the same argument that we have given for the nodes. Okay. So now you can see, so the same details till H. After that, you are seeing the IP address of the pod. This is the pod IP address. Okay, it's not the worker node IP address, it's a pod IP address. And then on which worker node this particular pod is running, right? And these are the different concepts. We'll discuss later what is readiness and etc. Is it-
Naveen, sorry to interrupt there. One IP address generated, right? Is that the second IP address what you're mentioning?
Yes, yes. Okay, so now let's say this particular web app pod is running on which worker node? This worker node, right? 31, 45, 229. Let's come back. So 31, what is the IP address of the worker node? 31, 45, 229. 31, not this one. I think the second worker node. 31, 45, 229. Okay, so this is the IP address of the worker node, right? 31, 45, 229. Now, what is the IP address of the pod here? 41, 31. 31, 41, 31. So where you can check it? So if you scroll down, go to the networking tab, you will find that IP here in the list. You can see here, this one, 172.31.41.31. Is it clear, Vijay?
Yes, Naveen. Correct.
Okay, so it will have some pool of IPs, right? Every worker node will be having some pool of IP addresses. Pool of IP addresses. Okay. Now from that pool, a random IP will be allocated to the pod. Is it clear?
Yeah, Naveen.
Yeah. And you can also check these details in the dashboard as well. Right now, I'm explaining with the commands, right? I'm running the kubectl pods. I'm checking with minus -o to check on which worker node it is running. What is the IP address of the pod? Okay, what IP is allocated? How many containers are running? Okay, all these details you can check in the dashboard as well, Kubernetes dashboard. So where? Come back to the Kubernetes, click on the clusters, open the cluster, go to the resources section, right? So this one, the first one, workloads, click on pods, and here you need to select the default namespace. Okay, I'm showing once again, cluster, resources, pods, select the namespace to default, and here you will able to see total number of pods that we created. If you select all namespaces, so sometimes it's like a tool issue, right? So when you select all namespaces, it will display all the pods. You can see when all namespaces is selected, it will display all the pods running on our EKS cluster. Okay, right. So if you go to the second page, we have these many number of pods. Total 14 pods. Out of 14 pods, 13 pods are already created. So we have not created those, but in a different namespace. What is namespace, that we'll discuss in the next class. Okay, but for now, you just select default, and here you can see the web app. Right? Okay, let's open this. And this is the pod name, and you can see the status running, and when it is created, what is the last transition time, on which worker node. See, this is the worker node, on which worker node this pod is running, and what is the pod IP address, on which namespace this pod is running, and how many containers. You can see the containers. Container 1, only one container. The name of the container is also web app. The pod name is web app. Container name is also web app. Okay, let's expand this. And you can see which image it is using. Nginx image. Container ID. Status running. And we have not given any specific port numbers or arguments or environment variables. That's why it's showing blank, blank, blank. And the events, like what exactly is happening in the backend. Okay, successfully assign the pod to so-and-so worker node. So who is doing this task? You can see the message, successfully assigned this pod to worker node, so-and-so worker node. So who has done this thing? Scheduler, you can see here from default scheduler. This is nothing but the kube scheduler. So kube scheduler has actually assigned this pod to so-and-so worker node. And then what is happening? It is pulling the image from Docker Hub and then successfully pull the image. Image download is successful. And then container inside that pod is created. Container has started. Okay, so you can check the events here. For troubleshooting purpose, if something goes wrong, you can come back to this dashboard. You can see like what exactly has happened. Right? So this is how we will be deploying our basic application on the Kubernetes cluster. But in the real time, you will not be deploying with the commands. There is a different approach, guys. So we will be writing the manifest files. So we will discuss that next class, like how to create a manifest file and how to deploy with the help of manifest file and all. Okay, but for the first deployment, you can also practice using the same approach, using the command kubectl run command. Okay, the very first deployment, you do it with the kubectl run command, and later on, we will be doing with the manifest files, Kubernetes manifest files. Right, I will stop it for today. It's 8:48. So if anybody have any questions in today's class, you can please stay back and you can ask me. I'll be available for next 20 minutes if you want. So you can ask the questions if you have anything. But Kubernetes is very, very important for the DevOps engineers. So please don't miss any classes, guys. Even if you miss any class due to any emergency or any urgent work, please watch that video on the same day and be prepared for the next class. Okay, right? So I'm repeating once again, Kubernetes is like a core concept for the DevOps engineer. If a person knows the Kubernetes concepts, like that person will be treated as like very great. Okay, if somebody knows Kubernetes, okay, he's like a next level kind of thing. So people will be having that feeling in the real time, because Kubernetes is like very crucial, important, and difficult subject. So if you ask me, Naveen, like what is a difficult subject or difficult concept out of all DevOps topics, I would say Kubernetes. But I will try to explain it like step by step, clearly, one by one. Okay, without any confusion, I will try to explain all the concepts slowly. Whatever the concepts I explained, at least like 10 to 12 concepts, all those 10 to 12 concepts, I will try to explain it in a slow pace. What I need from you guys, so you have to practice on every day. If you do not practice, you will forget. This is 100% sure. Okay, but whatever the support that you want from my side, please call me and ask me. I will try my best. But if you do not practice, if you do not put the efforts, I cannot do anything, right? So please put this in mind and practice regularly. Thanks, guys. I don't want to take much time. So it's already 8:50. Thanks for your support. Yeah. So if anybody have any questions, you can ask.
Thanks, Naveen.
Thanks, Sada. No questions?
Thanks, Navin.
Thanks, Bala. Yeah, you can drop off.
Thanks, Navin. Thank you.
Thank you. Thank you, Ravi. Thank you.
Thank you, Naveen. Thank you.
Thanks, Apesh.
Thank you, Naveen.
Thanks, Neetu. Bye-bye.
Bye.
Bye-bye. Ravi, Vijay, you have anything?
Navin, I want to discuss about the pod only. Like, I am aware of Kubernetes,
Mm-hmm.
so I have some knowledge.
Okay.
సో ఇక్కడ నా క్వశ్చన్ ఏమంటే ఇప్పుడు పాడ్ అనేది బయటికి మనం
Vijay, sorry, don't mind because this is getting recorded. Can you ask in English?
yeah pod like pod is there, right? I am aware of that one. Pod we can't expose outside. So for the internal, by internal communication we are using pod, right? So in the internal we are like deploying the some container.
Okay.
So like as I know, like a pod will communicate with the from one pod to another pod. We can communicate, right, with the pod IP.
Internal communication will happen between the pods, correct? Yeah, with
So
the pod IP.
here,
Yeah.
here my question is like, for example, in my container ID, some database is there. I want to move that data to the another pod into the another container. It is possible in the scenario, right?
No, that is the different scenario, Vijay. Okay. See, first of all, we will not store the data directly in the containers. Okay, because pods are ephemeral. What is the meaning of ephemeral? There is no guarantee about the lifespan of the pods. Pods can be terminated at any time. Okay, because of any issue, pods can be terminated. That is the reason we will not be storing data directly inside the pods. That means directly inside the container. Pods are nothing but, so what do we have inside the pods? Nothing but the containers only, right? So if you are referring to the pod, that means we are indirectly referring to the containers only, right? So now you are asking, can we store the data and move the data from one pod to other pod? We will actually not do that real time. Okay, so we will not directly store the data inside the pods. No. What we will do instead, we will configure the storage volume. Okay, so in Kubernetes, we have the concept called stateful set. Okay, Vijay. So we have the concept of deployment, stateful set, replica set, etc. Stateful set is something which is used for storing the data on the pods. Even if the pod gets deleted, still the data will be persisted on our EBS volume or any other storage file system. So in AWS, we have EFS, FSX, and we have EBS, etc. So depends on your requirement, you will be choosing the storage file system. Let's consider EBS volume. Now what you will do, you will attach that EBS volume to the Kubernetes pod, and then you will be storing the data on that particular volume, okay, on that pod. Okay, now if you want to transfer that data to the other pod, you can simply configure that volume to the other pod.
Here then why is the need for the pod IP at secondary IP address?
No, see, without pod we cannot actually communicate with the pods. Okay, because we will be having multiple microservices, right, Vijay?
Okay,
not just one single microservice that we are going to deploy on our EKS cluster. Okay, right. So internal communication means it's not just for moving the data from one pod to other pod. Okay, so for anything, let's say if your pods need to communicate with the master node, right? And like when you want to send the request from one microservice to other microservice, that pod IP should be available.
Okay.
You should treat the pod same as your instance, Vijay. So if I ask the same question, why do we require the IP address for the EC2 instance? So without the instance, how do you communicate with the application? No, right? So how can you access your application? See, I understand we will place the load balancer. Okay, all that incoming request is first coming to the load balancer. Let's say we have a Flipkart application. There are multiple microservices running on the Flipkart application. Okay, now we have different customers, different end users. Thousands of people are shopping on every day. Okay, now all that request first go to the load balancer, correct? From load balancer, where it is going to the pods only, right? Now load balancer should communicate with the pods, right? Okay, so without IP address, without pod IP address, how come the load balancer will understand, okay, so I need to send to these pods, I need to send to like communicate with this particular port number, this IP address? It's not possible. So it's for basic communication also we need the pod IP address, not just for like transferring the data. Is it
Yes, yeah, Navin, I catch your point.
Okay, got it? Okay.
Yes.
Same like our ECS task only. Even for the task also, we have the IP addresses, right? Okay, because every system should have a IP. And then we can use the port number, dedicated port number for exposing that application, for running that application. Right?
Yeah, Navin.
Yeah.
And I mean, that's it. I will do practice and I will come up with the question and doubts only.
Sure. So one more example is, let's say when you're running any front end or back end or database application on your pod, right? Now, if you want to access that back end application running on the pod, we need an address of the pod for communication, for accessing that application. Okay. And what is that address here? The pod IP address. Okay.
Correct.
So without the pod IP, you cannot access the application running inside the pod. It can be front end, back end, database, or anything. So if you want to,
In that scenario, we are using cluster IP, right? Like when we don't want exposed to outside.
see, I understand, but for the internal communication purpose, we need the IP address, right?
Yeah, I catch your point. I mean, yes.
Okay.
Yeah, I mean, I will do the practice and let's.
Right. So if you have any other questions, you can call me separately. Okay, we can have the discussion. So if you have any confusion with any other things, you can ask me. Okay.
Yeah, I will find sure.
Yep.
About the Terraform, you said you will do some practice questions or some interview questions. You said, right? So after the completion of this entire course, you will provide, or in between.
Interview questions I will give at the end of the course.
End of the course.
Yeah.
And one more question I want to drag, you are providing the some workshops, right?
Workshop? Yeah.
It will be like hardly 3 days, something I heard. Is it true?
No, it's not 3 days, Vijay. It's just a one day workshop.
Yeah, no, so yeah, fine.
Okay, it's just 1 day workshop. Probably it will be like like 3 to 4 hours workshop.
So seems like entire from starting to end.
Starting to ending. Yes.
Yeah, it would be great.
If required, I will take one more day, but most probably it will be completed by 1 day.
Yes. Yeah, Navin. It should be great. Yeah, Navin, thanks for clarification. We'll see you. Thanks.
Yep. Thank you.